All right, here we have to show that ABCD is a rhombus. So for a rhombus, the property would be all sides are equal and it has two pairs of parallel sides. So we want to have a look at the sides or the vectors of the sides. So for example, or not for example, but what we're going to do is have a look at ABCD. Now, I don't know if it goes this way, but we'll put it this way and we'll see A, B, C, D, for example. All right, so if I look at vector AB first, let's have a look at that one. These are the positions, so be a bit careful. So A, B, C, D are from these positions. So if I want AB, I'm going to take the B position minus the A position. So A plus B minus A, which is just B. And then when I look at B, where is B? B is 3, 2. Oops. Okay. I also want BC. So again, for BC, I want to take C, take away B. So that just leaves me with C, and C is 2, 3. All right, so that looks good because they're not a pair. All right, that's BC, so now I'm going to look at CD. Actually, what I should look at is DC, because I want that to be the same as DC. If that's DC, I want that to be the same as AB. So let's look at DC. So that means I take C and take away D, and that would leave me with B, if I'm reading that correctly. And B is 3, 2. So you can see those two are equal to each other, and of course the other one I found BC, so now I want AD. So AD, of course you would do the working. All right, take D and subtract A and you just get C, and so we already know C is 2, 3. So what we can say is, look, these two vectors are the same, exactly the same vectors, and we're using these are all joined by these points, and these two are the same vectors. Therefore, at the moment, we've got two pairs of parallel sides, and if we think about also their lengths are all going to be 3 squared plus 2 squared, and it doesn't matter. Same with same with BC, same with DC. Whoops. So they're all going to be the same length, and the same directions. So these are two pairs of, so what I would explain is that there are two pairs of parallel sides and they're all the same length side, so it must be a rhombus. All right, and then we have to find vector equation for the bisectors of the angles DAB. So DAB, so bisectors would be that line, and ABC, so the two diagonals. Basically, we have to find the lines. Now, we already know it's a property of the rhombus that the diagonals bisect. So therefore, we just have to find those lines. So let's find the line for AC. So first we'd have to find vector AC. Whoops, I need to just make some room here, which is tricky. So we need a point and we need a direction. So if we take the point A, where the position of A is, which is the only nice one here because it is vector A, so that helps us there. And then the direction will be given by the vector AC. So let's find AC, so we've got the direction. So to find AC, I'll do this one properly. So we're going to take C and subtract A. So we're going to get B plus C. And if we look at B plus C, okay, not so properly, we will get 5, 5 for AC. I might as well at the same time, I can see I'm going to need BD as well, so I'm going to put BD as well there. So for BD, I'm going to take, where's B? This is B and this is D. So D, which is A plus C, and minus B, which is A plus B. So just tricky here because you want to just go straight for B, but You can't. All right. So that ends up being C minus B, which is 2, 3 minus 3, 2. So we're going to get negative 1, 1. All right. So they give us both direction, and the other thing to note, well, let's do it in a second. All right. So if I take point A, position A, because that lies on the line AC. So remember, I'm finding the line AC. I need a point, so I'm going to take the point A, which happens to be negative 1, negative 2, and then lambda times the direction, and the direction is in the direction AC, so here it is here. So actually I can even divide it by 5 and make that 1, 1 to make it kind of neater. All right, what about line BD? So line BD, so we're going to take point B. Now point B, or position, is at A plus B. So I've actually got to add these two together. So 3 minus 1 is 2, and 2 minus 2 is 0. So I'm going to take that point, and then it's in the direction of BD. So I could do 1 minus 1 or minus 1, 1. Doesn't matter either way. All right, so there are two lines.